Here I have two instances of Linrad. One, this one, is running from a recording made on a 2-channel receiver with 2 antennas, and I think one is horizontal and the other vertical. The problem here is the ugly spur. We have it here, this one, and I have clicked on it, and it comes like this in the baseband. I have set Linrad to send the baseband in the wideband format to the network, and I pick it up with this instance of Linrad. The polarization control is set to fixed horizontal here, which means that what is sent to the next network is the same polarization as comes in from the hardware. I'm not rotating it in any way. And here I have set the polarization to fixed vertical, which means what you hear from the loudspeaker and what you see on the blue track is the signal from the vertical antenna. And I turn it up a little bit. And you can see, if we look at the spectrum, now when the signal is quiet, we have a lot of noise in both channels. But this is a strong signal. So for that reason, the demonstration is not so impressive as it would have been if there had been a weak station on the frequency. I can click here to rotate the polarization 90 degrees. And now we have it the other way around. We are listening to the blue curve and not to the red one. And you can hear that the interference is much worse now. So it is not equally... Well, the interference is equally strong in both channels, as you can see here. Red and green are the same, but the signal differs in amplitude between the channels. Now, the magic I can do here is to click on fixed and get adaptive polarization. This means that Linrad will maximize the interference. Here, you see it gets green, and you can see in the waterfall it is now stronger. But here, since I have set fixed 90 degrees, I'm listening to the opposite, and here the interference is gone completely. And you can hear from there is normal noise in the background. Not this ugly interference. And it's quite clear from the waterfall. And you can see here was an interesting event when there was QSB and the noise floor went down at the same time. It's here. I will now set the adaptive polarization instead to fixed and wait for this period in time to come back to demonstrate what actually happens at this particular moment in time. And as you can hear, having a fixed polarization helps quite a lot. And now we will soon come to that interesting part of the recording. And I will look at the polarization graph when that happens. Sorry, that was meaningless. I should have looked here. You can see the interference is coming up and the noise floor is not going down. The reason is, of course, that the polarization angle changes at that point in time. And I will click again on adaptive polarization. And then we will see what happens to the polarization. You can see it's fairly steady. It opens a little bit, that is the phase angle, and the rotation of the line, that's the amplitude ratio. And it's fairly constant. It means the interference is at the same level in both channels all the time. And now I will soon be there. You see the polarization changed for a while. And this ugliness here is replaced by a more silent region here. Now, of course, if the signal of interest happens to be suppressed at that point where the noise is suppressed at this moment in time, then there is no advantage. But this shows a property of Linrad that might be useful sometimes. Sometimes noise can be much more disturbing, many more of these unstable spurs that have a similar amplitude and phase relation. Like here, we have a strong one here, and I click on that, and you can see the amplitude relation is not exactly the same. Well, we are not on that anymore here. But this signal is drifting rapidly. But we can click, of course, on the... So, there are problems when other stations go in and destroy the phasing. But with a fixed phasing, we have this interference up here. It's not very strong here, or let's say it's more or less absent. While it comes at the level of, is it 10, 20, 30, 35 dB or so in the orthogonal channel. I can read from the S meter. It is 10, 20, 23 dB above the noise floor. But in this recording there are not many interesting signals. Maybe here. Well, I can change polarization. And as it happens, this signal is best heard in the combination where the interference is best suppressed. But there is no interference on this frequency, so it doesn't really matter.